This is lesson 11.3 with a focus on geometric sequences and writing rules and being able to write out an actual geometric sequence given a rule. So let's talk about what a geometric sequence is. When we add or subtract a common difference, we call that an arithmetic sequence. Well, when we multiply or divide by something, that's called a geometric sequence. And we're going to call the number that we multiply and divide by our common ratio, r. So let's take a look at a few examples. In example number 1, you can clearly see that I'm multiplying by 3. So it is geometric, and r is positive 3. In this example, here we're adding 2. So this is not a geometric sequence, this is actually arithmetic. Now this one, we can see we're dividing by 3, and when we're dividing by 3, another way to think of it is multiplying by 1/3 or the reciprocal. So this is in fact geometric, and r is equal to 1/3. And then our last example here, we can see that, well, gee, it doesn't look like we're adding or subtracting anything, but if I look close enough, I can see that maybe there's some sort of relationship there. When it's a little unclear, we're going to use a special trick to determine what r is, because sometimes it stands out to us and sometimes it doesn't. So in order to find r, what we're going to do is we're going to take the second term and divide it by the first term. And if we get the same thing each time, we will know that it's geometric. So let's divide it. Negative 12 divided by negative 8. Well, sure enough, that's positive 1.5. And then if I check it with a different set of numbers, if I take 18 and just divide it by the one before it, I should get the same number if it is in fact geometric. I get 1.5, sure enough. And then last but not least, I'll go ahead and check all the terms. 27 divided by 18 is in fact 1.5. So when we get the same common ratio each time, when we divide the term by the one just before it, we should get what r is, and it should be the same every time. So this one is in fact geometric, and r is 1.5. So again, sometimes it's obvious what r is, and sometimes it's not. So when it's not obvious, do our little division trick, and that'll tell us what our common ratio is, what we're multiplying by each time. Now, when we write a rule for a geometric sequence, we need to know two things. So here's our general form. We need to know the first term, and we need to know r. So taking a look at this sequence here, I know it's geometric because I am doubling each time, so I'm multiplying by 2. That means r is 2. And right here, there's my first term. So when I write my rule, all I'm going to do literally is just place the numbers in their spots. an equals 3 times 2 to the n minus 1. There's a1, there's r, just like in my problem, in my formula right above. There's my general form. And then I'm not going to touch it. I'm not going to do anything else. I'm not going to multiply any numbers because really I'm not allowed to. Order of operations says I need to raise things to exponents before I try to multiply. So this right there is as far as I can go. Do nothing else. So now let's take a look at this information. I still want to write my geometric sequence. I have now the third term is 20, but I do know r. So let's take a look at what this will be like. Here's a1, a2, a3. Those are my terms, and I know that this one is 20. And I know that I multiplied by 2 to get from a2 to a3. So the question is, what did I multiply with by 2? And the answer is 10. And then I'm going to do the same thing here. What did I multiply by 2? And I work my way backwards. So now I've been able to work back and find a1. I know what r is. So when I write my general geometric sequence, it's going to be my first term, 5, times r to the n minus 1. It's always the same, and there it is. I can't do anything else. So now let's try this one. Here I know that a4 is 16, so I'm going to draw 4 blanks. So here's a4, here's a3, 2, and 1. And I need to work my way back. And I know that if r is 1/2, that I multiplied by 1/2. In other words, I kind of divided by 2. So my question is, what times a half would give me 16? And here it's, whoops, not 36, but 32. And then what times a half, or what would I divide by 2 to get to 32, 64, and I'm kind of working my way backwards here. And I get my first term is 128. So here, an is equal to 128 times 1/2 to the n minus 1. All I do is put the numbers in place and call it good. And now last but not least, let's take a rule that we're given and actually generate the first 4 terms. So it'll look something like this. If I want to find a1, naturally, when we have a rule like this, really what we're going to do is we're going to take 1 and plug it in for n. Well, let's work it out in proper order of operations. 1 minus 1 is 0. Then I have to do my exponents. 2 to the 0 power is 1. And sure enough, I get 3. Now I should know this because that number right there is always my first term in a geometric sequence. So I should be able to just pull that out. Now if I want to generate the other 3 terms, a2, sorry, let's back up. Some technical issues with my podcast pausing. So again, I did some algebra to find a1. To find a2, I can plug in 2 for n and do the algebra. 2 to the 1 power, that's 3 times 2, that's 6. And I can do the same thing for a3 and a4. And I will get these 4 numbers as my first 4 terms. Now that's the long way to go about it. Let's do this an easier way. I know from my general form that this 3 is my first term. So I'm going to start out with 3. And then I also know that 2 is my common ratio. That's what I multiply by. So all I have to do here is say, okay, times 2 times 2 times 2. So 3 times 2 is 6, times 2 is 12, times 2 is 24. So I can do it very quickly that way if I remember how my formula works. So this has been all about geometric sequences, how to write your rule and how to generate your list for a geometric sequence.
Made with Doodlecast Pro.